Hey there! So today we're going to tackle a really important concept in algebra, inverse functions. We're going to use these slides to break down exactly what they are, how they work, and why they're so incredibly useful. Let's get right into it. Have you ever been in the middle of a math problem and just wished you had a rewind button? Well, it's funny you should ask because in the world of functions, you kind of do. It's called an inverse, and it's our key to undoing things. So here's our game plan. First, we'll cover the big idea, that rewind button concept. Then, we'll get into a really important rule called the one-to-one rule. After that, we'll see some inverses in action, I'll give you a heads up on some common traps, and finally, we'll talk about why any of this actually matters. Okay, first up, the big idea. When you get right down to it, an inverse function is super simple. It just undoes whatever the original function did. Think of it like retracing your steps perfectly, just in reverse. Now, pay close attention to the order here, because this is key. The original function says first, multiply by 3, and then add 5. To undo that, you have to go backwards. You have to undo the last thing first. So we subtract 5, and then we divide by 3. The order is absolutely crucial. And this leads us right to the formal math definition. All this fancy notation is really saying is that if you take a number, plug it into an inverse function, and then take that result and plug it into the original function, you'll end up exactly where you started, with x. It's a perfect round trip. All right, let's get to what is maybe the most important part of this whole topic. See, not every function gets to have an inverse. There's a really specific rule they have to follow. Yep, there's a catch. For that rewind button to work without causing any confusion, the original function has to pass a special test. It has to be what we call one-to-one. So what does one-to-one mean? It's pretty simple, actually. It just means that for every output, there is one and only one input that could have made it. Think about it. If an output could come from two different starting points, how would the rewind button know where to go back to? It couldn't. It would be totally stop. So how do we check for this? Well, thankfully, there's a super simple visual trick called the horizontal line test. You just sketch out your function's graph, then you imagine sliding a horizontal line up and down. If that line ever, at any point, touches your graph more than once, boom, it fails the test. It is not one-to-one, and it doesn't get to have an inverse. Okay, enough with the theory. Let's actually see how this stuff works with some real examples. This table shows the idea perfectly. If the original function turns a 1 into a 5 and a 2 into an 8, well, what does the inverse do? It turns that 5 right back into a 1 and the 8 back into a 2. To get the inverse, you're literally just swapping the input and output values. That's all it is.
And when you look at it on a graph, something really cool happens. If you draw that perfect diagonal line, y equals x, a function and its inverse are perfect mirror images of each other, reflected right across that line. It's a really neat visual way to check if two functions might be inverses.
So let's use our horizontal line test on a classic function, the parabola, g of x equals x squared. Imagine drawing a horizontal line up at y equals 4. What happens? It hits the parabola in two spots, right? At x equals -2 and x equals +2. Two different inputs are giving you the same exact output. That's a huge red flag. It fails the test, which means it is not one-to-one and has no true inverse. All right, let's talk about some common mistakes. These are the traps that are so easy to fall into, but if you know about them ahead of time, you'll save yourself a ton of headaches. Trust me. Okay, this is probably the single biggest point of confusion in all of algebra, so listen up. That little -1 you see in the notation for an inverse function, it looks like an exponent, doesn't it? Well, it is not an exponent. It does not mean 1 over the function. That's called a reciprocal. The notation f -1 of x is special. It only ever means the inverse function of f. They're two totally different things. So let's just quickly recap those warnings. Remember, that notation means inverse function. It is not a negative exponent. A function absolutely must be one-to-one to have an inverse, and your best friend for checking that is always going to be the horizontal line test. Keep those 4 things in mind, and you'll be golden. So you might be thinking, okay, this is some cool math theory, but so what? Why does this actually matter? Well, the truth is, you use this concept all the time in the real world, probably without even thinking about it. Here's a perfect example. Converting temperatures. The formula that takes you from Celsius to Fahrenheit, that's a function. And the formula that takes you from Fahrenheit back to Celsius, that is its perfect inverse. They are a pair of functions that just exist to undo each other, letting you switch back and forth effortlessly. So I want to leave you with something to think about. An everyday process like, say, putting on your shoes has a perfect inverse, right? Taking them off. But what about making toast? There's no untoasting button on your toaster. That process is irreversible. What other examples can you think of from your daily life?